Welcome to Senior Design Day, everyone. And I am Ablar Garcia, current VP Treasurer of College Engineering Student Council.
And I'm Brendan Lavelle, current AS Rep of College of Engineering Student Council.
How's it going to be today?
I think we're going to have a great day.
Yeah, let's check out the students at... So, what's your team name and what was the hardest part of the project?
We're the RAND product update.
We're the RAND's product update, and the hardest part of the project was debugging the main pick. I don't know. And getting the SD card to work from the main pick was the hardest part of our project.
Another difficult part was there was no documentation on there was no documentation on the old product, so we actually had to reverse engineer the entire project and find out what proprietary frequencies were used to communicate between the main board and the mobile map, which is a map that's interfaced with the main board. So that was the hardest thing, is to basically retrieve all the forgotten information. And after that, we had other issues on the board, but that's only because lack of documentation on new components. What's up, everyone? We have Audrey here with her project, and she's going to tell us a little bit about it and one thing she learned from her project.
Hi, I'm Audrey. I'm part of the ECE team of the baseball bat finishing system. And one thing that is important in working as a team is learn about everyone's strengths and weaknesses.
Hey guys, we have Matthew here, and he's going to tell us a little bit about his project.
Hi, so our team is for Project 35, the high airflow and heat transfer computer case, and we call our team Ice Core, and basically this is our high airflow and heat transfer computer case, where essentially we looked at a lot of models for conventional PC cases on the market, and we essentially looked them over and thought, what could we change and what could we do better? So one of the things we did was, in a lot of conventional PC cases, you have the power supply in the lower section of your PC, and that blows a lot of hot air into your component space. So we thought, hey, let's just isolate that in its own area and move it up top, and we got a lot cooler there. Another thing is, here in this bottom corner, you usually don't get a bottom exhaust fan, and that's usually because a lot of motherboards
to the moon, but allows them to live there. And so, like, this spacecraft would allow astronauts to live on the moon while and as you can see from our flight model, it has like light sensors where, like, if the spacecraft's facing the sun, then it would turn so that it's in like the sunlight. And so. And then we designed, my group and I designed like all the systems of our spacecraft, like the propulsion system, materials, like power system, communication system, and this would allow astronauts to communicate with the control center on Earth, and then the electric.
Hey everyone, so we're gonna ask this team how they're doing with their project.
Hi, my name's Elisa, and my team is Pacific Hydro Engineering. Right now we constructed a lift station as well as a pipeline for the city of Oceanside to kind of maintain the wastewater kind of effluent that they receive from tourism and like additional populations and things like that. So that's what we did. And we use kind of structural analysis. We use a lot of hydraulics. It's basically a team effort, a lot of geotech. So really multidisciplinary project. Yeah.
Okay, cool. Thank you so much. Hey everyone, we're with Thomas right here, and we're going to talk about his project.
So this is our AE 460 Senior Design Project, Life Investigation and Testing on Enceladus, or LIGHT. It's a mission to Saturn's moon, Enceladus, and we will be investigating for biosignatures there. This right here is a 1/7 scale model, so the actual satellite would be much, much bigger. So there's a subsurface ocean on Enceladus. And previous missions have tested for biosignatures, but it was more of a secondary mission requirement. And so our idea is to make it a primary mission requirement to sample ice plumes on Enceladus for, I believe it's 7 different biosignatures that might be indicative of life.
Wow. And what was the hardest part of the project? So Lisa, what do you recommend for future engineers?
I recommend really paying attention to your classes. Just listen to your professors. A lot of this stuff is in industry, so just make sure you do that, and also learn how to work as a team. That's very important, because some of these projects you might not get the best team or a team that you might want, like your friends, but it's better to work with different types of people. So I definitely recommend working with the team and really engaging with that.
Thank you, Alyssa. So, work hard, play hard, kids.
Tell us what advice he has for future engineers.
All right. So my advice for future engineers is that you should like really class and like do the homework, and like engineering's very difficult, especially aerospace, and so if you don't understand something, just go up and ask the professor, or just try to figure it out by like watching YouTube videos or whatever. And so if you like work hard and study and like do well on exam, or even if you don't do well on exams, if you understand like what you did wrong and stuff, then you can be like successful in the workforce.
Stay in class, kids. Hey guys, we have Daniel here, and he's going to tell us about his project.
Hello, Brandon. So this is Hermes the Air Tanker. I don't know if you can see it from the picture. Our motivation for this was the California fires. I think all of us can kind of see, even if it doesn't affect us directly up here. So wildfires produce around 140 billion in damages per year here in California. So AIAA kind of sent this request to proposal for a firefighting, and this is what we did. We went for size here. That's why it's called the air tanker. It carries 8,000 gallons. It has a max range of 3,000 nautical miles and a service radius of more than 1,600 miles, meaning that if it's in an airport and there's a fire 1,600 miles away, it can get there, and quite fast, since it reaches a maximum top speed at around 200 knots, so its dash speeds can get forward and backward. Another thing that we really focused was saving costs. So our design, although it may look simple, that's how it takes into consideration those costs.
We're here with Trisha, and we're going to ask her about her engineering project.
Hi, how's it going?
Yeah, it's fine. Yeah, go for it.
Oh, okay. So basically, our team is trying to design and build a fully 3D printed aircraft for our 3D pack competition in Texas. This is going to be in July, and there aren't really any design requirements or restrictions. The only thing is that we have to, all the electronics are obviously going to be just electronics, and then we have to get this thing to, our motor has to run for 8 seconds, and then after that we cut it, and then whoever glides the longest for the most amount of time wins. Yeah, so, and overall we kind of picked a flying wing because we wanted to make it as lightweight as possible, so that's why there's no tail, as you can see. But that means that we also have a lot of issues with control and stability, and
A little bit of advice for future engineers.
Hey, what's up, Brandon? Thanks for having me. You know what, if I could give one piece of advice, it would be to not give up, because the destination is the journey. Thank you.
Follow your dreams.
We're going to ask, what was your favorite part of the project?
So my favorite part was kind of just learning all of the aspects that go into the civil engineering and going into a building. So those are not really the things that are talked about, and that was pretty interesting to me.
my favorite part would have to be the structural analysis part. I had no idea how to go into how to do that project, but I talked to several professors here on campus, and they kind of informed me and guided me how to do that. So.
And my favorite part was working with the team and seeing what everybody was able to come up with. I know Solana came up with this whole rendering, so that was the best part of the project.
All right, cool. Thank you, guys.
And now the viewers want to know, what advice do you have for future engineers?
So I would say don't be afraid of the nitty-gritty. So with this project specifically, we initially were going to use the Arduino Du's default stepper library to control the stepper motors, and that's the easy solution, right? Well, hi, I'm Cruz. Our group is Ignite Innovation. This is an upward-facing cone calorimeter. I'd just like to talk about what the hardest part of this project was. We were one of the few groups that wasn't assigned an ECE team, which means we didn't have any help with electronics.
So the final question of the day is, what do you recommend for future engineers?
For future engineers, I recommend just being open with your ideas, because a lot of the time, even if it feels like everybody in your group maybe has like a better idea.
So pretty much what we left off is that what's the hardest part of the project?
The hardest part of the project, a lot. So I'd say probably integration was the hardest part of the project. So integrating the computer engine.
Hi guys, Brendan here with one of the two Baja racing teams, and
I'm Benjamin Johnson, and we're the Aztec Baja active suspension system team. So basically, we are building a active suspension system for...
and the viewers want to know, what hardships did you guys come across when doing this problem?
So there's a ton. So every individual member, so we did different things, and everyone ran into a different sort of hardship. So like personally, I worked with the filter, making the PCB. And
Hello everyone, so we're with Savannah, Jocelyn, and Fiona, and they're going to tell us about their project.
Valley Water Reuse Center. So this is going to be near the Snapdragon Stadium, right behind IKEA. So we designed this building with a 3D rendering, and so basically the building's about 7,700 square feet, has about 1,800 square feet of a vegetative roof. So it's LEED Platinum certified, and it's going to be about the total footprint about like 25 to 30,000 of that location.